All right, we're going to do area of regular polygons and composite figures today. The parts of a regular polygon is what we'll start with, and I'm going to highlight a couple of things. The radius and the apothem. You might understand what a radius is in that it's similar to the circle. If you see the little dashed circle around the outside of that figure, this regular polygon, which is a hexagon, is inscribed inside that circle. The radius is same as the radius of the circle. It goes from the center to a vertex, though, of the polygon. That's called a radius of the regular polygon. Another special segment that you've never heard of is called the apothem. That's a line drawn, is a segment that's drawn from the center perpendicular to a side at the side's midpoint. So it bisects the side. The formula that we're working with today is the area of this regular polygon is half of the apothem times the perimeter. Now the perimeter is adding up all of the blue part, the entire sides. That would be all the way around the outside. So take half of the apothem times the perimeter. And the perimeter is just going to be found by doing one side times the number of sides. The length of a side times the number of sides. So let's just try a problem. In this diagram, the apothem is here, and they've given it to be 4. The perimeter of the figure would be the distance around the outside. And all of the sides, these are regular polygons, which means the sides are equal. So all of those sides are 14. So the perimeter would be 14 times the number of sides, which is 3. And that would be 42. Well, I'm going to get a different pen because that thing's not liking to write for me. The highlighter, it wants to go straight. So that's 42, isn't it? 14 times 3. All right. So the perimeter is 42 meters around. The apothem is 4 meters. And we're going to do the area now. The formula is, area is the apothem. I'm going to do apothem times perimeter divided by 2. Just so we're constantly consistent. And we'll just multiply and then divide by 2. So we're going to do 4 times 42 divided by 2. That will be 84, and that's in square meters. So you're just following a formula, again, like we have been. Number 2 is now a different figure. The last one was a regular triangle or equilateral triangle. This one is a pentagon. It's a regular pentagon. It's already given us that the apothem is 6.9. That would be right here. Inches. And the perimeter, since there are 5 sides and each side is 10, you could add them all up or just do 5 times 10 to get the perimeter. And that's 50 inches. And now we're going to do the area. So the area formula again is multiply your apothem, 6.9, times your perimeter, 50, and divide that by 2. So grab a calculator. 6.9, excuse me, times 50 divided by 2. Okay. 172.5. And that would be in square inches. Stay on my screen there. Number 3. This figure has a side of 15. It's regular, so it has to be a square. It has 4 sides of 15, so I do 4 times 15 to get the perimeter, which is 60 inches. And, oh, no one told me the apothem. Oh. really not that hard to figure out since this is the center. If the whole side's 15, this is half of it. Yep. Sammy? Yep, 7.5. So the apothem is 7.5 inches. We can now do our apothem, 7.5 times our perimeter, 60, and divide by 2. Okay? Yes, you're right, Nathan. It is 225. Yeah, square inches. Thank you. That. All right, just kind of whipping through here, following the formula. This is what you'll have to know for chapter test and final. Length of a side is 10. There are 6 of them because this is a hexagon. So the perimeter is 10 times 6. 60 centimeters around. Now, careful. The apothem is 5 times the square root of 3. I can't explain how they got that. The angles in a regular hexagon are 120. They're all 120. Half of 120 is 60. The apothem bisects the base, so this would be 5. That's the side across from the 30 is 5. This would be 10, and this would be 5 root 3. That's where it came from. They already told it to us. The hard part's going to be how you type this in the calculator. So if you do your apothem, 5 root 3, and you multiply by 60, the perimeter, and divide by 2, let's see what we get. It'll depend on how you type it. Some people are going to get the answer wrong. Is anybody getting something different? Okay, it's right here. If you typed your 5 root 3, if you want to hit times 60, and you just do this, there's something wrong. This will not come out right. Why do you think this is wrong? That's right, they're all stuck underneath that radical sign. So you would need to type 5, and I'm just pointing this out because someone's going to have typed it incorrectly. When you are on these newer calculators, you have to hit the arrow to the right key to get out of the radical. Then you can hit your times 60, and then hit divided by 2. So the correct answer is 259.8. And that would be in square centimeters. You can avoid that problem also by typing it 60 and then times 5 root 3. But then you should probably hit enter and then divide by 2. So there's a lot of little ways you can have a problem with the typing. But it is 259.8. Okay, number 4. The apothem is given to be 11.5. The perimeter, 10. There are 8 sides, so it's 80. No, 10's the whole side. Yes. These are all 10. There's 8 of them. Okay, the area is 11.5 times 80 divided by 2. $460. Yes. Okay, square inches. Okay, now we're going to do some composites of figures. That's enough examples of doing the same formula. Composite figures. A composite figure is a figure that can be separated into regions that are basic figures. Find the area of a composite figure. Separate the figure into basic figures of which we can find the area. The sum or difference of the areas of the basic figures is the area of the figure. So some of them, I'll just make a little example. If you were going to put together a half circle and a triangle, which is sort of like an ice cream cone, you with me? You would do half a circle area plus the triangle area. But what if you were doing a triangle and you had half a circle cut out of it? Then you would do the area of the triangle and the area of the half circle and subtract. Okay, so that's where you would, the difference between an adding one and a subtracting one. These are just a bunch of the formulas that we've worked with. We're going to find the area of this. So we are going to split it into two shapes. The easy shape is the rectangle. Everybody sees that rectangle, I'm sure. It has dimensions of 30 and 15. So it's 30 times 15 for its area. So this rectangle is an area of 450 square units, square centimeters to be exact. Now, what about the ends? What's this shape plus this shape if you push them together? Yeah, a circle. All right, and the diameter of that circle is 15. Okay, so we're going to need to do the area of the circle. The area of a circle is pi times the radius squared. So we're going to do pi times the radius, which would not be 15, it would be 7.5, half of 15, because 15's the diameter. We're just going to type pi times 7.5 squared. You get 176.7 for the area of the circle part. So what's the total area? That's what our final answer needs to be. So the area of the figure itself, the entire figure, is 450 plus 176.7. So I think I'm just going to grab my calculator and hit plus 450 because I've already got the area of the circle on it. And that'll give me 626.7 if we go to the nearest tenth. And that's going to be in square centimeters. Okay, let's do a few more examples. Number 2, we've got a, what are my shapes? A triangle and a square. And you are right, it is a square because that's marked equal to this. This is 22. The square part is 22 times 22. And all of these were equal. That's a 22 also. What's the area inside her? 484? Someone check. 22 times 22? 484. Okay. All right, so that's the inside area, the area of the square part. Sorry, it looks really terrible. 484. Make it so I can read it. 22 times 22 is 484. Now, this is the next part. We've got to figure out the base of the triangle is 22, but what's the height? Where'd you get 20 from? Right, this much was 22. So if I do 42 minus 22, I get 20. There's my height of my triangle. Oh my gosh, that's way too bright. Nathan? Okay, So I did 42 minus 22, and that helped me figure out the height was 20. All right, now I'm going to do the area of the triangle. Area of a triangle is base times height divided by 2. So we're going to find the area by doing 22 times 20 divided by 2. Can we stop chatting, please? I appreciate it. Thank you. The area then would be, I could just do this one in my head by doing 20 divided by 2 is 10, and then 10 times 22 would be 220. So now I'm going to add those together and get my full area of the figure. I got to add 484, the area of the square, plus the area of the triangle. That's 704, yep, square centimeters. Thanks, guys. Oh, my. Where'd you make your error? Do you know? You have figured it out? All right, good job. All right, number 3. What are the shapes? Nope, they're not rhombi, guys. Thank you. They are trapezoids. Appreciate that enthusiasm there, Cade. All right. The area of a trapezoid, I'm going to find the formula. Say you didn't remember it. Base 1 plus base 2. You add those, you divide by 2, and you multiply times the height. Okay, now, it's turned sideways. We would like to know the height of it. Hold on. Hold on, guys. Everybody's not in the same place for a minute. This is base 1. Can you... I'm recording. I'd rather not use some reprimands. Names. All right, base 1, base 2. Gotta find that height. Cheyenne? You just came from lunch, hon. Unless, all right. Way too often. Kimmy. Pardon? 32. How'd you get that? Good job. Yep, 32 is the height because we cut 64 in half. Okay, so each of those trapezoids have a height of 32. So now it's turned sideways, so we've got a height of 32. And now let's plug the stuff in. We got two bases, 20 and 40. We add 20 and 40 and divide by 2. Then we're going to multiply by the height of 32. And I believe you already had that answer, Cade. But that would be just one of them, right? So, you know, right, 20 plus 40. It doesn't really matter what order I add because it's commutative. Then divide that by 2. And then we multiply by 32. Okay, we have one trapezoid has an area of 960. We need to double that because there are two identical trapezoids. All right, 1920 is your final answer. We'll put labels on it. The area of one trapezoid is 960. So the full area, okay, 1920 square meters. Sorry. Did you get your papers from yesterday? Okay, it's up there. All right, this is two triangles. Okay, the area of a triangle is base times height divided by 2. So let's find the area of one triangle. The base would be your 35. What is the height? Yes, it is, because it's half of 15. Each of these would be 7.5, and both of their bases are 35. So let's get the area of one triangle. One triangle's area would be 35 times 7.5 divided by 2. Okay, one triangle area, what was it? 130. Okay, and then we're just going to double that to get the total area. What's the matter? I'll do it on the calculator. 35 times 7.5 divided by 2. Then we have to double that because we have two identical triangles. So our final answer is 262.5 square yards. Yes. Well, good observation. What was the point he said of dividing by 2 if you have to multiply by 2? It technically does cancel out. So if you showed that you were multiplying, trying to get your total area, you could have hit times 2 right here, cancel those out, and then you could do 35 times 7.5. It will give you the answer. Okay? All right, so the rest is assignment you want to try to work on. I want to go to the review for the quiz tomorrow that does not cover this. It covers through 11:3. Yes. I'm just trying to find ready for, let's see, where's my one for, I made a new one, 2017. Here we go. All right. These are similar to questions that are on your quiz tomorrow. They are very similar, but of course the numbers have changed. They are not the same numbers. Okay, so find the area of this parallelogram and round to the nearest tenth. I am missing something that I need because I know the area of a parallelogram formula. You go look that up, base times height. Do I know the base? Well, yeah, it's 10 because if that side's 10, this side's 10. All right, so my base is 10. All right, so I'm trying to find its area. So I've got the 10 for the base, but I don't know the height. So there is a hint on the quiz. It just says, hint, use trig or special right triangles. A lot of you have done okay with the special right triangle pattern. So let's think about it. There's a special right triangle pattern on the wall. There's one on the wall over there and one on the wall over here. I pointed. If this is your short leg, it's n. The long leg is 2n, and the hypotenuse is 2n, and the long leg is n times the square root of 3. This has a hypotenuse of 8, so the short leg would be 4, and the long leg would be 4 times the square root of 3. That would be your height. So that's one way to get the height. Then you could go ahead and just multiply, and you would be done. Some of you do not seem to get the special pattern. So you could use half of 8 and then 4 times the square root of 3 for the height. Now, I will do it a second way because it does not matter to me which way you get your height. If you were to use trigonometry, which we have learned, from the 60-degree angle, the height is opposite the 60, and the 8's the hypotenuse. Opposite and hypotenuse is the sine. So we could have done the sine of 60 equals h over 8. And then you would have calculated 8 sine 60 for your height. If you do 8 times the sine of 60, then you would have 6.928, which I'm going to need to round to 2 decimal places, 6.93. That is the answer to the area. The answer to the area is, I know what this is. So it's 3. Absolutely. I will look. You didn't do anything wrong. That's your answer. I was showing another way to get the height by itself. So I hadn't multiplied by 10 yet. So if I hit times 10, I would have my area, 69.28, which is 69.3. Okay, I wanted to show you again that 4 root 3 is identical in value to 10 to 8 times the sine of 60. You see, 6.92, blah blah blah. All right. Either way, I want 69.3 for your answer. Okay, number 2. A right triangle. Oh, and this would be in, sorry, square centimeters. Okay, a right triangle has legs of 5 and 7. I'm going to sketch a right triangle. Where are the legs? They're, yeah, and this is the hypotenuse, so they're the other 2. It doesn't really matter which one you call what. It can be flopped from what I wrote. Area for a triangle is base times height divided by 2. The legs are the base and the height. So we're ready to go. 5 times 7 divided by 2. And that's 35 divided by 2. So you should be getting 17.5 square feet. Okay. Oh my word. Are you all right, Sam? All right. Oh my. I have a little humor going on. Okay. Number 3, area of the kite. You want to look up your formula. Area of a kite is diagonal 1 times diagonal 2 divided by 2. Yes. Okay. Well, you're very lucky that you get all the formulas because a lot of places don't allow that. They make you memorize them. All right. This would be 6 going that way. And then going this way is 12. So real simple. We're just going to do 6 times 12 divided by 2. So our area for this kite will be 36 square centimeters. Real straightforward basic problem. Some of them are like that. Some of them are going to be worked backwards. Okay, the next one tells me I have a trapezoid. It has base length. I'll just let the first one be B1, 6.5 inches and 14 inches, B2. And an altitude, which would be the height, of 8. So I've got 3 components given to me. Then it also says, oh, it says what is the area of the trapezoid. So we look up the area formula. Area is base 1 plus base 2 divided by 2 times the height. Okay, so we're popping this in. We've got 6.5 plus 14. We're going to add those first. We're going to divide that by 2, then multiply by 8. You might want to use the parentheses if you're going to try to type it all at once. Oops, I forgot to put mine in early. Plus 14 divided by 2 times 8. Yep. The area is 82 square inches. Okay. Number 5. It says find the area of rhombus PQRS. It's a rhombus. So I look up the formula if I don't know it. Diagonal 1 times diagonal 2 divided by 2. First, you're going to need to use the Pythagorean theorem. We have a hint here to find the length of one of the diagonals. Well, I know this is 6. This is 6 here because the diagonals of a rhombus bisect one another, or for all parallelograms. So I've got one diagonal of 12. I got to figure out the other one. It says this is 6.5. I might not have seen it. I'm sorry, I had to slide it up there. 6.5 would be here. Anywhere you want to think about it, that's 6.5. So now, well, I meant any of the sides are 6.5. We need this length. Okay, so I'm going to put an X on it. That is a leg of a right triangle. So to figure out the missing diagonal, we have to do x squared plus 6 squared equals 6.5 squared. We have to apply our Pythagorean theorem in order to find that diagonal. 6 squared is 36. 6.5 squared, I might not know that one in my head, so I'll go type it. That's 42.25, 42.25. We need to subtract 36 from 42.25, and that's 6.25, and then we have to take the square root. Square root of 6.25 gives us an x value of 2.5. All right, now that means we got one, but not just one 2.5, we have 2, that's 2.5 also. So the diagonal itself is 2.5 plus 2.5, which is 5. All right, so diagonal 2 is 5. Let's plug it in the formula. Our area then is going to be 12 times 5 divided by 2. And that's going to be 30 square centimeters. 12 times 5 is 60, half of 60 is 30. Okay, this one we're going to be working backwards because we're going to find the height. Trapezoid has bases of 4. Let's let B1 be 4, B2 be 20, and area A is 60. Find the height. That's what we're trying to figure out. So I'll write down the formula. This is what I suggest you do. The sum of the bases divided by 2 times the height. Some teachers put the h in the front. Some people take half the height, then do the second part. We're doing average the bases and multiply by the height. All right, I'm going to pop in what I've got. I have an A of 60, so I put that in where the A goes. I have a B1 and B2, so I add those and divide by 2, because that's in the formula. And I multiply by h, which I don't know. Okay, so let's do this part. 4 plus 20 is 24, and half of 24 is 12. So here I am. I've got 60 equals 12 times 8. So all I have to do is divide by 12, and I've got my height. 60 divided by 12 is 5. So the actual height of the figure is 5 feet. Okay. Somebody still need this? Okay, the base of a parallelogram is twice its height. Got a parallelogram. The area for a parallelogram is base times height. It says that the base is twice the height. So I'm going to let the height equal x. If I let the height equal x and the base is twice the height, then I would write the base is 2 times x. It says the area is 98. A equals 98. So now I'm going to go ahead and fill in 98 for A. Base is 2x times height of x. That gives me 2x times x would be 2x squared. Divide both sides by 2. You get 98 divided by 2 is 49. And then you take the square root of both sides in order to get x alone. So I've got 7. Yep. It could be plus or minus, but we certainly don't need a negative height. So 7, which one is 7 now? Your height's going to be the 7, and it's going to be in feet because the area was in square feet, and we unsquared it. And the base will be 2 times 7, or 14 feet. Okay, you will have a problem like this with different numbers. Okay, number 8, I'll write down the formula for you for area of a sector. You would go look on your sheet, find area of a sector. It is x degrees out of 360 times the area of the entire circle, which is pi r squared. We're doing part of the area. So for this problem, 15 degrees out of 360 times pi times 20 squared. .4 square feet. Yes. Oops, I wrote 54. It's 52, right? 52.4 square feet. I hope you've been working along because it's going to help you tomorrow. Right, we're going to have a problem where you're going to find area and circumference, and I will have blanks, one for the area, one for the circumference on the quiz. You need to do 2 different formulas. Area is pi r squared, circumference is pi times the diameter. This figure has a diameter of 18, so what's its radius? What's its radius? 9. Thank you, Amato. So our area is going to be pi times 9 squared. Round to the nearest tenth. I probably wouldn't mind if you just wrote 81 pi. That would be an exact answer. But since it says the tenth, we'll go on the calculator and do pi times 9 squared. And that's 254, and then to the 10th would be 5, 254.5. Square inches. Now, in the circumference, we're just going to do pi times the diameter, which was 18. So we're just going to hit pi times 18. And that's 56.5 if we go to the nearest tenth. Now, what's the label on that, though? Yeah. No. Just the inches. I heard inches and I heard inches cubed. We will be doing the cubic inches in the next little unit we're doing when we do volume. You do not have to do cubic inches right now. I'm thinking this is probably the easiest question on the thing, except you know what? Some students do because they're kind of like lazy and don't want to think too hard. It's got to be the reason, because I guarantee you, I know you know that this thing has 4 sides, not just 2. I will see people add just 8.2 and 12.4 for the perimeter. Please. What? This is, okay, guys, area is base times height for this figure. No divide by 2. Perimeter is 2 times a base plus 2 times a height. Okay, you got 2 bases and 2 heights. All right, 8.2 times 12.4. Please don't talk like that. I'll take care of it. $101.68. It didn't say what to go to, did it? So I'm just gonna write the whole thing because it was on the calculator all there. And the perimeter, 2 times 8.2 plus 2 times 12.4. I shouldn't even have to write the answer down. Okay, 11 is a straight up area formula for the trapezoid. You've been given everything you need to do its area. It just has decimals. So you're just going to pop in the numbers. I don't care what order you add those bases, and then multiply by 3. All right, we have just a few problems left here. Our work backwards. I would like you to try to do those at home. When you come in tomorrow, I will go over those briefly and collect your review. Have a great